Cool. So what I want to say is a couple things. Number one, worksheets 7 and 8 is due today. If you have not already submitted it to me, you got to either email it to me or give it to me on paper. I'm going to make the solutions visible probably around noon or so. So once I go on Moodle and make the solutions visible, I will no longer accept any of those assignments. Okay. So actually quite a lot is due today, and only because, not because we did a lot at once, but because I've extended assignments a couple of times. So just so you're aware, again, the worksheet 7 and 8 is due, let's just say by noon today, either email or live. And also lessons 12 through 14 are all due by midnight tonight. I had a due date for lessons 12 and 13 much earlier, but as you know, I first extended it until over break, and then I extended it a couple more days after that. But I can't extend it any further. So please make sure you get these things done. Okay. I will talk about the whole class and grades and all of that as we proceed over the next week and a half. But I will let you know that, and I mentioned this at the very start of the semester, in the end, I dropped 2 low worksheet grades. So I take the best 8, and that becomes 20% of your grade. And your online homework in the MyOpenMath, that's not moved over to Moodle yet. I don't move it over until the semester is done. But I also dropped 2 low assignments in the MyOpenMath before I transfer your grade over to Moodle. So I feel like there's wiggle room here, right? Like I want to give everybody, kind of the benefit of, like, there's a lot of assignments and we forget to do things sometimes, or we struggle with things sometimes, or what have you. So please know that, in the end, 20% of your grade comes from the online homework, and that's after 2 scores are dropped. 20% of your grade comes from those class activities. And again, that's after 2 are dropped. If you missed either, some in here or here, those are the ones that are dropped. And then 20% of your grade comes from test 1, 20% of your grade comes from test 2, and then 20% of your grade comes from test 3. So, I really try to evenly distribute it so that not everything is like really high stakes, like, oh my gosh, I'm going to freak out about these things, but rather more formative assessments. Cool. Awesome. All right. So what I want to do is I want to pick up where we left off class yesterday. If you were here, you know that we left off class with a total cliffhanger, right? And I hope you all were still able to sleep last night wondering how in the heck we're going to solve this. But you may or may not recall, we had X being the number of transistors we could produce. Y was the number of resistors we could produce. And Z represented the number of computer chips that we could produce. And when we set up our system, we came up with these. Okay. So yesterday, Hopefully, if you did miss class yesterday, you were able to catch the video. Otherwise, it's going to seem like I'm talking about gibberish. But yesterday we worked on setting up systems. We'll be doing more of that today for sure. Okay, but we came up with this system. And while we know how to solve a system of 2 equations and 2 unknowns, this really brings us to a different level. Okay, and so we finished off class yesterday with me saying something sarcastically like, oh my goodness, what do we do from here? Okay, well, what I'm going to do is I'm going to talk to you a little bit about this. Okay, and then we're going to work on, I had mentioned yesterday, today's a technology day. So if you have your calculator with you, I urge you to get it out. Those of you on Zoom, I recommend you get it out too. I will show you how to push the buttons on the calculator. Okay, now what I'm going to show you with the calculator, you can actually solve 2 equations and 2 unknowns with that as well. I still want you to know how to do it using the addition elimination method, but you can at least use your technology to check. Now, it used to be the case when I would teach this Math 115 course that we would, at this point, have to spend a whole entire week or 2 studying things called matrices. Okay. Matrices are a huge area of study in math. They're so totally cool. But we don't need to get that in depth with it because we now have technology that can solve these things for us. So when I first started teaching this course 30 years ago, we didn't have the technology in our hand to be able to solve these things. So we would have to do them by hand. Okay. And maybe some of you have heard of the Gauss-Jordan elimination method or the echelon method. Your book might even mention those. We don't even have to go there, okay? But I at least want to give you an idea of what's going on and then show you how to plug it into your calculator, okay? So what I want to say is as follows. Matrices are, yeah, they're really cool. But anyway, I need to keep to the point here. Okay, so the question is, how do we solve a system like this? In other words, now we want to find the values of X, Y, and Z that satisfy all 3 equations at the same time. Okay. And it used to be the case that what we would do is we would have to essentially solve these matrices, and it was not an eco-friendly way because it was so much paper. Okay, so before I get to telling you how to put this in matrix form, what I want to do is talk about something that is going to seem totally irrelevant. Okay, suppose I have this equation, AX equals B. If I wanted to solve for X, how would we do that? Just using the algebra that we've used thus far. You would divide both sides by A, wouldn't you? Right? You would need to get X alone, you would need to move this A over to the other side. And in this case, what we would do is we would divide since we're multiplying. Okay. It turns out you can't do matrix division. It's just not defined. Okay. But do you agree, if I had 3x equals 7, equivalent to saying divide both sides by 3, I could say multiply both sides by 1/3. And isn't 1/3 the multiplicative inverse of 3? Right? Because when you multiply them together, you get 1. Okay. So while you can't divide with matrices, you can multiply by the inverse. So essentially what we do is we take a inverse and multiply both sides by a inverse. This, okay? And a inverse times a, just like 1/3 times 1, or 1/3 times 3 becomes 1. You're just left with an x equals a inverse times b. Okay, so essentially in something like this, when you can't divide, you can look at it as, well, we can multiply both sides on the left by a inverse. Okay. All right. So what do I mean here? Well, essentially, when you have a system like this, you're going to write this as a series of 3 matrices. One of them we're going to call A, one of them we're going to call X, and the other one we're going to call B. A is what we call our coefficient matrix. Coefficients are the numbers in front of the X, Y, and Z. Okay. So, for example, if I wanted to write my coefficient matrix here, A, tell me what my top row would be. Well, what are the numbers in front of X, Y, and Z? 3, 3, 2. How about in my second row? 1, 2, 1. And how about my third row? 2, 1, 2. Remember, when there's no number written in front, it's going to be 1, or if there's a negative sign, -1. You with me there? That is what we call our matrix A. Our matrix X that we ultimately want to solve for are our variables X, Y, and Z. And our matrix B is what these guys are set equal to. Are there any questions how I took that system and rewrote that in matrix form? Now, what this involves at this point is ultimately we're going to want to solve A inverse times B. In other words, the inverse of this matrix times this matrix. Okay? This is now all about plugging things into your calculator. You ready? Cool. So what I'm going to do now is show you how to enter this sort of thing into your calculator. I have both this TI-36X Pro calculator that we are lending out free of charge this semester to show you, and I also have this TI-84, and TI-83s are very similar. Okay, so I'm going to show you how to enter these things into your calculator. Again, I don't like spending a lot of time teaching people how to push buttons on a box, but I think it's important to show you all how to use this, and then you have the video to refer to in case you forget. So I will start out using this calculator right here. Okay. So those of you who are using the TI-36X Pro, the freebie ones that we gave you, what you're going to do is you're going to look closely here, and you're going to see that there's this button here that says math, and then in blue right above it, it says matrix. Do y'all see that? Okay, so in order to get to the matrix, in order to enter the matrix, right? In order to enter the matrix here, you're going to hit second math. Okay, and you should have something like this. You with me there? Cool. I appreciate your thumbs up because that helps me know that you're tracking. Okay, now when you enter a matrix, you do edit. When you want to do math with the matrix, you go to math. When you just need the matrix to show up, you go to the names. So for example, if I scoot over here, you see number 3 says inverse. We're going to need the inverse of A. Okay. Now, the first thing we need to do is we need to edit these. So the first thing I want to tell you is the way we talk about matrices is we talk about the size. Okay. And the size of a matrix is the number of rows by the number of columns. So for example, my matrix A has 3 rows and 3 columns. So I would say that A is a 3 by 3 matrix. My matrix B has 3 rows and only 1 column. So I would say it's a 3 by 1 matrix. All right, so I want to enter this in for my matrix A. So I go over to edit and then I hit enter. And notice they ask me for the number of rows and number of columns. Okay, so I'm going to go over to 3 rows, hit enter, and then I'm going to go over to 3 columns and hit enter, and then I'm going to hit OK. And now what you'll see is that we can enter matrix A. So you go across, so you hit 3, enter, 3, enter, 2, enter, and then 1, 2, 1, and then 2, 1, 2. All right. Now you can get out of there if you want by hitting second mode to quit. But now I need to enter my matrix B. So what I'm going to do is I went back into the matrix. I go to edit and I go down to B and I hit enter. Now we see that there's 3 rows and 1 column. And I enter my digit 765, then 385, and then 470. So once you have those in, now what you want to do is as follows. Are y'all with me? Okay. If I'm going too fast, tell me to slow down. So now what I want to do is compute this A inverse times B. So the way you do it is you go to second matrix. We just want to talk about A, so I'm going to hit enter. But now I want to do the inverse of it. So I have to go back into the matrix thing and I go down to inverse and hit enter. Do you see how now it says A inverse? Now I'm going to hit times and I want to multiply it by matrix B. So I need to re-enter my matrix and I go down to B. And there we have it. What this is telling me is that X is 95, Y is 90, or Y is 100, and Z is 90. In other words, this tells us we can make 95 transistors, 100 resistors, and 90 computer chips. Heck yeah. So how do we do the A inverse times B? You go second, math. You're at the names. So you hit enter. Okay. Now we want the inverse. Do you want me to write this down as I'm doing it? So TI 36X Pro. So what you do is you hit second math and then you hit enter right away, and that should give you A. Then what you do is you go again into second math, but you go over to math and then hit number 3, inverse. And now what it should look like is A inverse. And then you hit times. And then you're going to do second math again and go down to B and hit enter. And there you have it. Yeah. So that's with the TI-36X Pro. Those of you who have this TI-84 or TI-83, it's going to be pretty similar. I got to just find, matrix here on this calculator is this, it's right below the math. It's X to the -1 power. And then it says matrix above that. So you're gonna, for the, let me put this to the side here. For the TI-83-84, the way you get to the matrix is you hit second X inverse. Now, you might not have anything here, or you might. The whole point is once you edit it, it overrides. Now, this sort of calculator is a heck of a lot more expensive, but it also has a heck of a lot more capability. You're not limited by a 3x3 matrix. You can do pretty ginormous ones here. Okay. So the way you get into the matrix is you hit second X inverse here. Now, if I want to edit matrix A, same steps. I still go to edit. And now I enter the size. I hit 3x3. And then it'll automatically grow and shrink as needed. And then I enter my matrix 3, 3, 2, 1, 2, 1, and 2, 1, 2. Once you've entered that matrix, you can quit and get out of there. But now we need to enter matrix B. So I go over to edit, and I'm going to go down to B, and I'm going to hit enter. Notice it's a 3x1, and I enter these values. So the editing is pretty much the same in both of these. It's just how you get there is slightly different. Now to do the computation here, what you're going to do is you're going to hit second X inverse, and then you're going to hit enter. And that'll give you the A. Now here, you don't even have to go into the math for it. You could just press X inverse button. And then times. You go to second matrix, you go down to B and hit enter, and you get the same solution. Haley, we're going to be doing another one in a second. Which do you need help with, the TI-83 or the TI-36? Oh, yeah. So essentially, once you have the matrix in, see how there's this X to the -1 button in matrix? You just press this X to the -1 button to get the inverse. So again, the way you would do it is you would hit second X to the -1 to get into the matrix. Here's matrix A. So you just hit enter. Now I hit this inverse button, this X to the -1. And now I hit times. And now I need to get back into the matrix to get my matrix B, I hit enter, and then you hit enter again. Haley, is this okay? Or what do you need me to go through? I want to make sure that I meet your needs here. After I put in the number, here, let's practice doing another matrix example. Okay. I think that's the best way to go through that. All right. So what I'm going to do is take us through another example. Haley, can you tell me, Riley, I see that you have the TI-84. Haley, can you tell me what kind of calculator you have? So I know you have the 84 also. Okay, that will help me out. Okay, so let's do one right from like the start. Okay. So this is a word problem, whole 9 yards. Now, I want to tell you that this word problem is very similar to one that you have on your online homework. Okay. Oh, this makes me hungry already. We're going to plan a meal. And our meal is going to contain rice, tofu, and peanuts. Does that make you hungry too? No? Okay. All right. So here we go. There we've got that. Now, this meal must have 30 grams of protein per serving, 14 grams of fat per serving, and 50 grams of carbs per serving. Doesn't that sound better already? And what we want to know is how much of each ingredient should be used if each cup of rice, let me say cup of rice, contains 4 grams of protein, 0 grams of fat, and 44 grams of carbs. Each cup of tofu contains 20 grams of protein, 10 grams of fat, and 5 grams of carbs. And finally, each cup of peanuts contains 35 grams of protein, 72 grams of fat, and 31 grams of carbs. Ooh, sorry, this is all poured copy here. All right, let me know when you have that written down or take a picture of it, whatever helps you. Those of you in here, give me a thumbs up when you got it. You ready? Ish. All right. So this is going to practice a couple of things. First, it's going to be to translate our word problem. You may or may not remember from yesterday, but the first thing that we do is define our variables. And the hint that I gave you yesterday to define your variables is you go to the question that is being asked. That tells you exactly what you're looking for. Okay, so let's go to the question. How much of each ingredient should be used? Okay, well, I'll let X be the amount of rice. In this case, it's measured in the number of cups. I'll let Y represent the amount of tofu, and Z represent the amount of peanuts. Do you all see how this follows very much from what we were doing yesterday? You literally go to the question and it says exactly what it is you want to find. And so we set our variables to be that. Questions here? You okay? Kristen? Okay, cool. All right. The next thing that we do, and don't worry, we're going to get more practice with this in the next couple sections as well. The next thing that we do is we set up our system of equations. And my hint to you yesterday was to go to the totals because that tells you how you want to set up each equation. And the totals that were given here involve the amount of protein we need. It involves the amount of fat we need. And it involves the amount of carbs we need. So what this tells us is that our first equation is going to be all about the contributions of protein from each of these ingredients. So we should have an X, Y, Z in at least most of these equations. Okay, so what the first thing we want to do is talk about our protein. Let's talk about protein. Okay, well, each cup of rice contributes 4 grams of protein. Each cup of tofu contains 20, and each cup of peanuts contains 35 grams. So do you agree that the total protein contribution will be 4x, right? 4 grams per cup times the number of cups plus 20y, 20 grams of protein for tofu times the number of cups of tofu plus 35z. Okay, now what we're going to do is we're going to look at the amount of fat that each of these contribute. Notice my rice does not contribute any fat. So we could put 0x if we wanted to, or we could just leave it out. And then our tofu contributes 10 grams, so it's 10 grams per cup times the number of cups. And our peanuts contain 72 grams per cup times the number of cups. Do you see the pattern of this from yesterday? And then finally, we have 44, 5, and 31. So 44x plus 5y plus 31z. Questions on how I set this up? Okay, so this is what we practiced a lot with yesterday. What we're now going to do is take this a step further, and we're going to write these as matrices, A, X, and B. So my A matrix is my coefficient matrix. It's just the numbers in front. So what does my top row look like here? Well, what are the numbers in front of X, Y, and Z in my first row? 4, 20, 35. My next row, 0, 10, 72. And my bottom row, 44, 5, and 31. Here we're using X, Y, and Z. And what does my matrix B look like? 30, 14, and then 50. All right, are there any questions how we went from this system to this? So now what we need to do is we need to enter these into our calculator. Okay. So I will take us through this one by one with each calculator. All right. So those of you with the TI-83, TI-84, you ready? Cool. We need to enter matrix A and matrix B. So recall the way you get in, there's that word matrix, is you hit second X -1. Whenever you're entering matrices in, you go over to edit. And it's at A, so I'm going to leave it there. Notice A is a 3 by 3 matrix still. And now what I do is I enter according to the rows. So I'll hit 4, then enter. 20, then enter. 35, enter. 0, 10, 72. And finally, 44, 5, and 31. Okay, we got to get out of here. So second mode quits it. But now what we need to do is we need to enter matrix B. So again, I'm going to hit this second X to the -1. We're going to be entering a matrix. So we go over to edit. But now I want to edit matrix B. So I go down to B and I hit enter. It's still a 3 by 1. But now I need to enter these values. So 30, 14, 50. All right. You ready for me to do the computations, you guys? So now I'm going to compute the A inverse times B. So I go second matrix. I'm at A. So I hit enter. See how there's this X -1 button? That's how you get into the matrix. You just press that straight up. And now you hit times. And now we want to get to matrix B. So you go second matrix. You go down to B. You hit enter. And then you hit enter again. So this says we need about 0.98 cups of rice. We need about 1.27 cups of tofu. And 2/10 of a cup of peanuts. Those of you who are using this this calculator. Again, here you get to it by hitting second math. We want to edit. We want to edit A. Again, it still has 3 rows, 3 columns. And now we enter these values: 4, 20, 35, 0, 10, 72, 44, 5, and 31. Once you've entered this matrix, you can go in again to the matrix, go to edit, but now we need to edit matrix B. And that's still a 3x1. And now I need to enter these values. So 30, 14, and 50. All right. Now we do the computation. So you hit second matrix. We want matrix A. Now we need to go back into the matrix to get to the inverse. That's the difference with this calculator. But you go over to edit and you go down to 3 and hit enter. And then from here, it's the same: times matrix B. And there we go. Was that better? Those of you on Zoom, did that help me going slower? Awesome. Awesome. Cool. Well, this is really good timing because there's only a few minutes left. And I want to show you something very quickly. Let me go here. I'm going to share my screen with those of you on Zoom, so just hold on 1 second. All right. I have just a few minutes left. So what I'm doing now is I'm telling you that we just finished lesson 15. Let me show you some things. Okay, first off, I'm going to set the online homework to be due a week from today. Holy smokes, I cannot believe this. It's December 6th, the week from today. And what I want to do is just take you through this a little bit. Okay. Now, this is meant to be really helpful to help all you guys navigate your homework. Okay. Question number 1. It says solve this system. Question number 2, solve this system. Now, you could use the matrix function on your calculator to do this. But I will tell you that there is one problem on your last test that I do ask you to use the addition elimination method. I know, but I love your facial expression anyway. But you can check it using the calculator, right? These would just be 2x2 systems and a 2x1. This one is very similar to what we have been doing. They want you to enter what matrix A would be and what matrix B would be. That's it. You're not even solving it. Here, they're asking you to write out what each equation would be. This is translating. The thing that you have to do is use their variables. They use C for chocolate and O for ornament. Make sure you use their variables. Okay, but this is very similar to the one we did with theater seats yesterday because one of the things involved money and the other one yesterday involves seats. This involves number of boxes. Question 5 is a calculator problem. Question 6, again, this one asks you to write the equations using S for students and A for adults, and they want you to solve it. They say your own paper, I say your own calculator. Here's another one that you solve using your calculator, and another one that you solve using your calculator, and another one that you solve using your calculator, and another one that you solve using your calculator. This is the rice, tofu, and peanuts business. All right, awesome. Happy to answer questions as always. We have only one more homework assignment for me to open and go through. This is so exciting. All right, I hope you all have an awesome day.